Hi, my name's Relevant, and today in the shop, a 1972 Garnet Revolution III with a reported reverb issue. So contrary to popular belief, this is not a retro hardware channel, it's a do all the things channel, and one of the other things that I do is I work on old tube amps like this. I tend to know my way around them, which is good because I couldn't find a straight answer on the schematic for this guy. Now, the first strange things we notice about this guy is the reverb tank is on the side of the cab. Usually it's on the bottom, or in some cases even bolted to the bottom of the chassis, but on the side, And unfortunately, because of how this thing's laid out, I'm gonna have to take this apart in order to diagnose anything, to see what tubes do what. Oh, that screw looks rather chowdered. All right. Oh, okay. And I swear I got the amp like this. There's a 6L6 just kind of, you know, I thought it was peculiar that this amp only had one 6L6 tube, and I'm feeling around and I can't really find another socket. Oh, there it is. It's at the other side of the transformer. Okay, the fact that a tube just up and fell out, you know, lends some clues as to why this amp is broken. That's quite amusing, actually. We also have random broken crap kicking around in the back of here. That's not good. Wonder where this came from. Oh, mismatched screws. That's great. Now I kind of want to get this reverb tank out, and it's you know, permanently affixed into there. Can the cables? No. The cables are hardwired into the chassis. So this reverb tank's got to come out. Ooh, got some dusty here. Now I'm curious about something. Seeing as how this is a reverb issue, I'm gonna inspect the tank real quick. Oh, that's an interesting looking tank. It's got some general Z pattern to it with two different size springs. Reverb's interesting because you have a preamp tube that's basically set up like a power tube, and it pushes through a drive transformer. That right there is essentially like a kind of speaker, except instead of driving a paper cone, it drives a spring, causes this spring to vibrate. And then on the other end, that's like a guitar pickup. And then that gets pumped back into a preamp and then blended into the rest of the circuit. We're gonna need to color code this, I think. Oh, the reverb tank looks healthy at least, so we know that's not our problem. And it's just phono connects onto there, right? Set that aside. Folded line, reverberation device. Manufactured by beautiful girls in Milton, Wisconsin, under controlled atmosphere conditions. Manufactured by beautiful girls. Okay. I don't know if that would be legal to put on your merchandise these days. On the other hand, I don't know, Asians are kind of cute. Everything's made in China now. All right, let's get this pupper flipped over. Okay, so yeah. We're missing a tube shield on what's probably one of the first preamp stages, so that's kind of important. One tube definitely fell out. I wonder how long that's been like that. I don't see a transformer for the reverb driver. A chunk of chassis is missing and has wood over top of it. I wonder if that's factory. 4 tube complement, 12AX7, 12AX7, 12AU7, 12AU7, 12AX7. So I'm imagining preamp, phase inverter, and then reverb and tremolo. This does have tremolo, and tremolo is an easy circuit to run. And 2 6L6s, but one's missing. One clue to the problems with this amp is the fact that these tubes are quite ancient. Hitachi Raytheon? Okay. Sylvania? How do these guys sound? Not bad. They don't sound completely like a bucket of bolts. If your tubes sound like a cat climbing up a Christmas tree, they're done, even if they do still work. Now, one philosophy that I hold dear when some people ask me to work on these old kind of amps, I say, if you're not willing to retube them, then there's no point. And in our Canadian dollars, that could cost upwards of $200. So that's basically a base quote price I might give someone for this project. Because yeah, all these tubes are old, and this reverb issue could be as simple as a blown tube. Now, unfortunately, we kind of have to take the chassis apart to diagnose which circuit is which, because that's the other thing. Like, I need to inspect on this to find out the health-wise, because you also have issues of really old capacitors like this, which are great and all, but, you know, these are consumable parts like tubes too. There's some people who debate the purity of an amp if you start tampering with it like that, but, you know, it's like changing the tires on a car. And we have a 40, 40, 30, 30. So it's a quad capacitor. Ooh, 12AX7A, made in Japan. That still sounds tight. They're all matched. Well, you can't really tell the tightness by tapping them when they're inert. You kind of have to have the amp running. But all the 12AX7s are matched. Oh, this one's even Garnet labeled. Original tubes. That's not good. Like, nice little collector item, but you gotta change them out, bud. And of course, we have mix match screws, which is always awesome. That looks like it was originally one of the Reverb screws. Now that the tubes are out, we can be a little bit more rougher with this thing, but not really. Be kind. Hoi, 2 different kind of screws here too. Oh, what is this? That screw wasn't even doing anything. This amp's been haphazardly worked on over the years. Okay, so the chassis is one of the strangest shapes I've ever seen a chassis. And we just have this, you know, little wooden bunker there sealing in the one section. Point to point, not even pegboard. Ah, yeah, you see here? That's the Reverb driver transformer. It's inside the amp, but yeah, it has connects to this wire, and then that wire goes around and under, and that drives the transformer. That's probably the output. And the other one returns and goes to here. So that's one of the Reverb tubes. Last one, eh? I would have thought that would have been the phase inverter. Power transformer's loose. Oh yeah, this needs, that needs to be tightened up. Most in here looks health. Similar components that I'm used to seeing in old trainers. And of course they have ye old pin 1 to pin 4 bridge, which is a feature I never like. Basically, pin 4 is the screen grid, and before the screen grid goes this resistor right here. And the most convenient way to wire up that resistor is to go from the main power comes to pin 1, and then the resistor connects over to pin 4. Now that sucks because it means you can't use EL34s in this amp because pin 1 needs to be ground. 6L6s don't have a pin 1, so that's an inert pin, and it makes great for a little binding post. Why is there tape wrapped around this output transformer connection? We're gonna pretend we didn't see that. All right, so power tubes. Trying to remember my pin outs here. Pin 6 appears to go back to here, and they connect to this tube. So it looks like this tube is part of the phase inverter. Now where's the tremolo? Speed and depth. And then there is the tremolo's cascading capacitors. And then they seem to hook up to the other side of this tube. So this tube is both reverb and tremolo. Okay, we're making progress now. Now what drives the reverb? It appears to be this wire here, which connects to this tube, the other half of this tube. So this tube's doing double duty. One half of it's the phase inverter, the other half of it's the reverb send. Then we have reverb return and tremolo over here. Input jack comes to here, first gain stage, goes to gobbledygook. Volume returns here, second gain stage. First gain stage for channel B. And then I'm kind of losing track of it after that. Feedback comes in here to the bottom of pin 8. So this looks like that's phase inverter also. Maybe that's all phase inverter. Hold on, what is this? Oh, that's a power source right there. Okay, we're looking at it wrong. This appears to be reverb send. Yeah, that's a power supply going to the driver. Blue comes off the driver. That's reverb send. All right, so inquiring minds want to know, where's the bias circuit on this thing? Because that's, you know, one of the single most important things that we have to worry about. It's partially related to this. That's the power supply circuit. We have our bridge rectifier, and then we have this tap and this reverse diode, and then that, and then this yellow wire here. Where's this yellow wire go? That yellow wire connects to the depth knob, of course, because that's how some tremolo works. It varies the bias on the power tubes, and that gives it a really deep sound, because it's not just turning the volume on and off, it's like modulating the power output of the amp itself. Oh no. This thing's fixed bias. Damn, I hate fixed bias. It is very difficult. Well, not really. It means you gotta go in there and you gotta change the value of a resistor. All right, so can you see in here? Can you see in here? Yeah, power supply comes in here, or the power transformer comes in this side, and then you have what's, I believe, called a half-wave rectifier going to here, to this end, and then that is your main power for the amp, goes to the filtering capacitors. But right here, power is tapped off the transformer, and then it goes through this reversed diode to give negative current for the bias. Now that resistor right there, that's your bias resistor. That bleeds current to ground to set your negative voltage, which adjusts the power of the tubes. So basically, in order to bias this amp, you have to change the value of that resistor, which is annoying to do. Especially, she's buried down there, bud. On a riveted board. That's not gonna be easy to get at. All right, so if I've got this right, preamp, half preamp, reverb driver, phase inverter, reverb return, and tremolo. So if we have a bad tube, it's either half of this one or half of this one. Now we have to move on to a bench testing phase of this operation. Basically, get some fresh tubes, at least preamp tubes, and then I'm going to check the bias that the old tubes are running at, and then build from there. Okay, so I got an all day got bench test set up here, reverb tank reconnected. I got an external cab going, and I found a mixed bag of tubes. Here's some Sovtech 12AX7 LPSs, excellent sounding tubes, though just a touch more fragile than I'd like. These tubes are a bit old, so they've gotten a touch microphonic, but they still work perfectly good for demonstration purposes. I don't have any 12AU7s that I want to put into this thing. They're in my good amps and they're my good tubes. But Sovtech 5751s should be good enough for now. They're all interchangeable, AX7s, AU7s, AT7s. It's just your gain structure's gonna change a bit. But in this situation, it's not gonna be a big enough deal for testing. And then, right here, I got myself a bias testing tool that I made, where I basically took a tube socket and soldered it to the ass end of an old broken tube. And I can go ahead and pop that in here and allow me to judge on how hot these old tubes are running. That's one reason why I don't like these alligator clips. They don't fit with all bases. It was that Hitachi Raytheon that was in here, wasn't it? Fortunately, I can't really get zapped from this end. Gotta be careful still. I probably could get zapped from this actually. And basically just clip my meters onto these leads here. So he had but one power tube in here. Let's see how he was running. We're getting 480 volts on the voltages. Milliamps are starting to come up. 45, 46. So that's 453 is what the voltage settled into, times 0.045 is 11 watts idle. So these old 6L6 GCs, they're gonna be 25 watt tubes. We're gonna say 30 because that's generally what 6L6s are now. Divided by 450 volts, 0.66 times 0.7. We should have, oh frick, our bias should be about 46. So that's one of the great things about the old tubes that the new tubes don't have. They were because they were mass manufactured the way they were, quality control was tighter back in the day. And it's not because we can't do quality control today and things were done better then. It's because they were mass manufactured in massive quantities because everybody needed and used tubes. So it was more economically feasible to cull the batches. As a result, biasing amps wasn't as important back then because, you know, most tubes of a certain rating or a certain model would just kind of slot in where they needed to be. So this guy's gotten lucky that even though one tube's popped out, his amp's still running where it needs to be. I'm gonna go ahead and move this guy over to the slot that it's supposed to be in, or another slot. Then I gotta put the tube that seems to have fallen out, who knows how long ago, into this slot, and then fire it up, see what this guy has to say. First thing we're noticing on the voltage, we've dropped down to 434 volts. So more voltage drop with more voltage load. And this tube's only biasing at 28. Oh! Buds. Something suspicious. My workbench GFCI protection popped. Well, that's somewhat subject to controversy. We've got ground leakage on this pupper. Maybe GFCI doesn't like hot chassis. That's how these things were, they were hot chassis. the negative voltage that runs the whole circuit is being pumped through the entire chassis. GFCI might not like that. 434 times 0.028, that's a 12 watt idle. So that is abnormally low though, it seems. If we got a 30 watt tube, divided by 434, that's 0.69 times 0.7. That thing should be running at 48 milliamps. So that tube's weak. Let's see how it sounds like this. She's a bit hummy, but that could be because we have an open chassis. Hey, the reverb's back. That kind of touches on something that I suspicioned. But wait, reverb's not supposed to work on that channel. Maybe it works on both channels. Oh, it's way thicker on the other channel. Wow, it's got a very different sounding reverb with that Z coil. I've never heard a reverb like that. It sounds more like that surf reverb you hear about. Reverb hums a bit, but other than that, the amp's like perfectly dead silent. It was buzzy when I got it, but it was missing a tube. One of the reasons why they use two tubes is because they work in kind of a push-pull configuration, and as a consequence, like humbuckers, they're kind of wired out of phase with each other in such a way that hum picked up by the other one is canceled up by hum picked up by the other one. Same thing on here. Hum that might be produced in one half of the circuit gets canceled out by the hum that's being produced in the other half of the circuit, and that was a trick they used to make amps quiet. This thing was hummy and dead sounding when I got it, but that's because it had old frickin' tubes, and one of them was missing. But now it's completely silent. Yeah, I think it's a case of just new tubes, but I bet you if I put those old 12AX7s on the tube tester, one of them's probably half dead. Or maybe the fact that one tube was missing, the phase inverter got confused and I don't know. So this amp, I think it's in perfect working order. He just needs some fresh tubes. So what we're gonna do now is we're gonna play around with some different tubes to see if we can find a sound that works for him. And because it's a fixed bias, I'm gonna go through some of the power tube 6L6s that I have to see if I can find a number that's gonna work for him. Now, some of the best advice I can give to anyone aspiring to tube amp is that, if you only ever change your tubes like once every blue moon when you think they're wearing out, and you just get the bog standard variety, cheapest ones, you're doing it wrong. What you should have on your shelf is a variety of different tubes and different flavors and colors so you can swap them around, find out what best floats your fancy. If you're not doing that, you might as well just get digital modeling, because that's the whole purpose of tube amps. These are light bulbs of tone that come in different colors. The whole point of having a tube amp is to play with different tubes to find the different sounds. A 6L6 is not just a 6L6. Here, I have Sovitech 6L6WXT in a number 20, a Tunxol 7581 in a 15, a 7581A in a 23. The 7581As are a different name for a 6L6, so they're compatible. Now, one of the reasons why I got these is because they have the different numbers, 15, 20, and 23. This is going to allow me to narrow down the bias of this amp. I purchase all my tubes from tubestore.com. They're out of Hamilton, so being a Canucky, that makes it rather convenient than having to order from far and wide. The service and prices have been generally good, and they come pretty fast. Now all the tube store tubes, they have this number rating on them. Generally, if you bias and set up your amp for the specific number of tube, then when you need to reorder, you just ask them for that same number and you're golden. So we're gonna start with these 15s and we're gonna see where they sit on the bias scale. And if they sit in pilotable range, then perfect. I just tell Buddy, okay, we get you some tubes in this size and you're good. And that saves us the trouble of having to tweak on that resistor. All right, so we're getting 448 volts and 18.8 on this tube. Now they're not gonna be perfectly matched, so we gotta kind of swap them around to do an average. But as it stands right now, that's about 8-9 watts idle. At that voltage, we're looking for 47 milliamps. So 15s might be too cold for them. Now also, we want to let the tubes warm up good and hot before we really judge them. But we're going to go straight to the 23s here to see what they read. Now unfortunately, I don't have the biggest variety of tube values because I basically reorder them in a general specification so that I don't have to hugely rebias my amps. Okay, so now we're sitting in a more palatable range. The higher the current, the lower the voltage drop. So that's one tricky part about biasing an amp. You just can't go by a fixed voltage. The ratio switches around all over the place on you. But according to this, that's 15 watts idle. Our target is still 49, 48, 49. At this point, I might email Tube Store and say, if 23s give me 37, what number do you recommend to get 48? I don't know, they got some pretty skilled technicians there. They might actually have an answer for that. Either way, we can tell this amp's biased a bit cool, which chances are these will be fine. Wonder if they sound different. For the record, I'm running a parallel humbucker mode in this right now. Now, what I will do here is I will turn this thing up a bit to see what readings we get. Because even though the bias is rather cold, we could see different results once we dime it up, especially if your capacitors are worn out. I was seeing peaks at about 55. We'll say 55 at 415. That's 22 watts, so that's gonna be 44 watts. 390 at 85, 33 watts. You know what, 23s might be good. 23s might be good for them. This thing actually has a bit of distortion. Some of the best blues tones you ever hear come out of the old, worn out amp. Dime it out, see what happens. We're gonna say roughly 370 at 100. That's putting out some current there. 37 watts, 37 watts. So that's a little bit of overdrive. Maybe we should go down a notch from 23. Bear in mind, I'm also running my phase inverter a bit hot with a 5751 instead of a 12AU7. That could, which one's the phase inverter again? That one? I have a 12AU7. Let's just bite the bullet. Yeah, just to confirm that our phase inverter isn't overdriving our power section, 12AU7. Now let's get the Solvetech WXTs in here. They're a tube that I sometimes recommend for, you know, just a working man's amp. Even though they're not the best sounding tubes, they're not the worst sounding either. Not the cheapest also. 427 at 32, not warmed up yet. I popped GFCI again. Oh boy. Admittedly, that's a little bit suspicious. Can't remember the last time I've plugged an old tube amp into GFCI. I've plugged it into AFCI all the time in the other room, no problem. Everything in this house is either AFCI protected or GFCI protected. So I've gone ahead and plugged the workbench into the one unprotected plug that I have for the purpose of testing evaluation. 380 at 100, 38 watts. That's per tube. It's running a little hot, but I'd say for these purposes, that's probably okay. $370 at 108, 39 watts. Now we're gonna do a little flopsky here just to check the balance on these guys. Can't just trust them right off the bat. Buddy said this thing is super loud, but I don't know, pretty average to me. But then, I'm used to some big rigs, aren't I? You should see my bass rig. Fully up, 218s and 810s. $364 at 116, 42 watts. Okay, so 20s it is. $420 at 42, 17 watts. Okay, so yeah, if I just get up some tubes in the 20 range, he should be fine. He should be fine. Now let's get some fresher preamp tubes up there, because I know what preamp tubes I'm gonna recommend. JJ ECC83S's. They're a good, cheap, robust tube. Can't go wrong with them. Not the best sounding tube in the world, but you know, you got a lot of playing around. Now I have some tongue saws and some other tubes in inventory that I can do some tone modeling on here, but that would take a lot of time, and my tongue saws, they're buried in my bass head that you need to take apart with screws and stuff, so I'm not pulling them for this. So 12AX7, 12AX7, an ATA7, or an AT7, we'll put that in this driver position. And if it sounds good with these tubes, we'll call it good. Now, mind you, I'm not currently testing it with his cabinet. I'm testing it with one of my cabinets with Celestia G12 L35s, but whatever. Might be a bit harsh. We're trying the 7581s again. They're a nicer tube, probably even more money though. I think the 7581 sound better. I'm gonna plop in a combination I'm rather fond of for one of my personal amps, where it's an ECC 83 MG in the first position, and then an EC3 803S in the second position. Now the 803S is not recommended for combos because it's got a longer plate design that's more susceptible to microphonics. And then I think in this position I would put the other 803S because that's combination phase inverter. That's the phase inverter? No, the phase inverter I'd want a tongue saw. Oh boy, this is where stuff gets confusing. I can't remember what tube's what here. This is tremolo and reverb return. And I think this is send and also, okay, we've mixed it up a bit here. I think I gotta go through this amp with a fine tooth comb and get a better determination of what tube does what. Allow me to better recommend. Something about that tube combination dampened the reverb. Oh, it seems that changing the reverb send makes a profound difference in the depth of verb. Yeah, if you put a 12AX7 in this position that says 12AU7, you get verb you could just get lost in. Okay, I'm gonna recommend a 12AX7 in that position. And of course, the amp doesn't care. Well, the fact of the matter is we could be here all day playing around with different tube combinations, but I don't know. I'm gonna have to message this guy, consult on him as to what he wants to do. So I'm gonna get back to you on this on a part 2 when we finally decide what we're doing with it and what tubes are coming in.